Alright, so we have some exponential expressions that we need to simplify. Even though a fractional exponent at first may seem a little intimidating, but remember that when we define negative and rational exponents, our main motivation in the choices we made was so that the good old rules of exponentiation remain the same. For example, this rule is still true. It doesn't matter how crazy the exponents are, so all we have to do is just add the exponents. So what we have is x to the 1 over 7 plus 1 over 14. 14 is the common denominator, so we're talking about 2 over 14 plus 1 over 14, which is 3 over 14. Again, a to the n over m is the same as mth root of a to the n. So this here is the same as 14th root of x cubed. These are both simplified correct answers. This is exponential notation, this is radical notation. When you see in the instruction, present your answer using only positive integer exponents, that means you cannot use, this is not an integer. That means you have to go to this form. Here, the only exponent is a positive integer. Usually this is considered to be more simplified. So the question should be clear what format they want the answer, but if you're not sure, just use this. So our next problem is a division, and just like in the case of the previous problem, this rule of exponentiation is still true. So all we have to do is subtract 2/3 from 3/5. So it's x to the 3 over 5 minus 2 over 3. So the common denominator is 15. 5 to 15, that was multiplication by 3. 3 times 3 is 9. 3 to 15, that was multiplication by 5. And 2 times 5 is 10. So we have x to the negative 1 over 15. So this might be a final answer, but if you should give your answer using only positive integer exponents, then the negative can be made go away by interpreting it. Remember, a to the minus n is 1 over a to the n. So x to the minus 1 over 15 is the same as 1 over x to the 1 over 15. And x to the 1 over 15 is 15th root x. So this here is the same. This here is the same as this. Okay, what do we have next? Okay, so the next one is x to the 5 over 8 further exponentiated to the power of, again, it doesn't matter how crazy the exponents are, those very basic natural rules of exponents still remain true. So repeated exponentiation means we can multiply the exponents, and that's what we're gonna do. So this equals x to the whatever 5 over 8 times 2 over 15 is. Lots of cancellations in this one. We can get rid of the 5 and leave a 1, and then this leaves a 3. So both 5 and 15 are divisible by 5. So we can cancel out 5 and also a 2. So we have x to the 2 is disappearing, and then we have 4 times 3, 12 in the denominator. So we have x to the 1 over 12 or 12th root of x. So these are the two different forms of the same, hopefully correct answer. Alright, so let's see. The last one is basically the same sort of things, it's just a lot of them. X to the 7 over 5 divided by x to the 3 over 5, and the entire expression is further exponentiated to the power of 5 over 6. So there are going to be two steps here. First, we're going to use this rule to simplify the expression inside the parentheses, and when we're done, we're going to use this rule to simplify the repeated exponentiation. So inside the parentheses we have x to the power of 7 over 5 minus 3 over 5, and when we're done, exponentiated to the 5 over 6 power. Okay, so 7 over 5 minus 3 over 5 is 4 over 5, and using this rule we can multiply 4 over 5 and 5 over 6. A nice cancellation, 5 is gone. So we're left with x to the 4 over 6, but that's the same as x to the 2/3. or third root of x squared. Final answer for this question. Thank you for watching.